All right, so the last thing we're going to look at with simple harmonic motion is a pendulum. So what a simple pendulum is, it's a mass at the end of a lightweight cord. We assume that the cord does not stretch and that its mass is negligible. That's what we're going to use when we talk about a simple pendulum. So in order for it to be simple harmonic motion, the restoring force must be proportional to the negative of the force, negative mg sine theta. So that's this right here, right? Which is proportional to sine theta and not to theta itself. However, if the angle is small, sine theta does equal theta. So you can see here the situation where those could happen, right? It's pretty close as our angles are small, but as our angles get bigger, there's a lot more difference between the sine and the actual angle. Therefore, for small angles, the force is approximately proportional to the angular displacement. The period and frequency are, and here's your two equations, okay, for period and frequency, or for period. So for a small angle, the period is 2 pi square root of length over g. Nothing to do with mass, because mass cancels. Frequency is just 1 over, flip what's under the radical for small angles, okay? So as long as the cord can be considered massless and the amplitude is small, the period does not depend on the mass. Huge point. Almost guarantee there's a multiple choice problem on the AP exam that will have something similar to this on there. So how we can use a pendulum to measure G. Geologists use a simple pendulum that has a length of 37.10 centimeters and a frequency of 0.8190 hertz at a particular location on the Earth. What is the acceleration due to gravity at this location? Do it now.
Okay, so we're going to look at measuring G. We have a simple pendulum with a length of 37.1 centimeters and a frequency of 0.8190 hertz, and we want to find G. So we want to solve for G. Again, let's multiply both sides by 2 pi. So 2 pi frequency is square root of G over L. Square everything, so 2 pi squared f squared equals G over L. Multiply both sides by L. Length times 2 pi squared times frequency squared gives me G. And now I just substitute in. So my length I said was 37.10 centimeters, so 0.371 meters. 2 pi squared, and my frequency was 0.819. And I solve for G. And when I solve for G, I get 9.824. So pretty good in measuring G on Earth where we're at. Must be pretty close to sea level.